Okay, so hello everyone, this is Akshay here, and let us resume with the third question of our list of the bit manipulation. The third question is the majority element. It's an easy category question, but let us see how many approaches are available to solve this question. We have been given number of arrays and we need to return the element which appears more than n by 2 times, right? So for this, integers here 3, 2 and 3. The n by 2, like the total number of integers is 3, 3 by 2 which gives you 1. So the element which is appearing more than once, that will be your answer. And you can clearly see 3 is appearing more than once and that is our answer. Similarly for the second test case, how many elements are there? 1, 2, 3, 4, 5, 6, 7. 7, right? The 7 by 2 will give you 3. So the element which is appearing more than thrice will be our answer. So clearly we can see that there is only one element, that is 2, which is appearing more than thrice, that is appearing exactly 4 times, and that is our answer, right? Okay, so how we can solve this question? So first and foremost approach is about that we can count the frequency of each and every element using a nested for loop, right? And we will not discuss the brute force techniques. We will discuss all the techniques, but we'll code only the efficient one, right? So the method 1 is clear. Method 2 is we can store the frequency in a map, right? And we can then again traverse. So it would be exactly O of n to store the frequency of all elements in the map, and then they have said that the element will always exist in the array, right? So while storing as well, we can just check if the frequency has been greater than the n by 2, then and there break the loop and return the key. So O of n, and O of n would be the space complexity. Again, method 3 is O of n and O of 1, but this is a very standard algorithm, Moore's voting algorithm. We will discuss it in the array section. Till then, you are feel free to read about it on any other site like GFG and whatsoever. Now we have a method 4 where it also takes O of n as time and O of 1 as space. But this approach is using a bitwise, right? Prerequisite for this question is if you're solving this question, then you must know the previous question which we have solved, the single number 2. It's just the variation, you can say, right? And you should know how to check if kth bit is set or not. Now if you know these two things, then definitely this question will be very easy to you guys to solve this using bitwise. So let us write. So again, we will open all the given numbers in a 32-bit binary system, right? So let's just open the decimal into the binary system. So 3 will be written as 1 and 1, 2 will be written as 1 0, and 3 again will be written as 1 and 1. Just wait. Okay, so we're gonna need to count all the number of ones present in the bit system at the current bit place. Let's say for the last bit, what is the count of number of ones? There are 2 ones I can see, so the count is 2. Again, for the second last bit, what are the number of ones present for all the numbers? Cumulative, we are finding it, so it is 3, right? We will check if the count of 1 at each and every position of the bit, if it is greater than n by 2, then can we say something? If the count of bit at each and every position or at the current position for all the numbers, right, if it is greater than n by 2, can we say something? Yes, we can say that that particular bit is actually contributing into the answer, right? If I say that the count here is 2 and n by 2 is nothing but 1, it is greater than 1, right? Then definitely this bit is contributing in our answer. And what is the weightage of this at this position? Since this is the first bit position, so it will be 2 power 0, then the weightage will be 2 power 1, then weightage will be 2 power 2 till 2 power 32 or 31, right? So since the count is greater than n by 2, let's sum up the weightage. So it is 2 power 0 and 2 power 1. So 2 plus 1, which will give you 3, and you can see 3 is your answer, right? So I hope we had the intuition how to solve this question using the bitwise. Now the next thing I need to explain you, or you should know, that how to check if the kth bit is set or not. So let's say this is your kth place and I need to check if it is set or not. So what I will do is that somehow I will make this number. I will have a 1 here on which I need to check. For rest all the places I will have 0 and I will AND it, right? Since these places are 0, then definitely I do not care what is the set bit, or if I do not care about the positions in the actual given element if it is set or not. If these are zeros, and since we are doing an AND operator, definitely all the bits would be 0 except this one. Since we have placed 1, so definitely the answer would depend on the bit in the given number, if it is set or unset, right? So if it is 1, it would be 1, and definitely if this would have been 0, let's say, then our resultant also would be have 0 here, right? And if you see what is this number, this is nothing but 1 shifted left shifted k times, right? So that's one approach you can do. So there is another approach as well. And second approach is explained in this single number 2. You can go back and see that question. Let us see the code now. So that's the code present in Java, that we have a for loop going for 32 times, so that is opening all the decimal number into a 32-bit binary system. Then we have a count, and we are checking for each and every number. We are finding the count, right? So that's the first way to check kth bit is set or not, and that's the second way. This is again actually doing the same thing but not in one line, right? So again, count plus plus, and at last we are checking once we have rendered all the elements, we have checked all the elements for the current position, we are checking if the count is greater than n by 2, then definitely that bit will be the part of our answer, and then we are contributing the weightage of that particular bit into our answer, and we are returning the result. That is it. Let us hit the submit button. Okay, so so that's got submitted. Great. So what's the time and space complexity? Time is over n and space is over 1. So that's the C++ code. Again, is the same thing that we have done in Java and in the dry run. No need to explain it again, and that's submitted. Great. Let us meet again in the next question of our playlist. Till then, keep learning, keep growing. Bye-bye, and take care. And if you have liked my video, understood the problem and the solution, please like, share, and subscribe. Till then, keep learning, and bye-bye.